nothing was written on there. Alright, here it is. Now, we talked about restricting the domain. It's restricting it to all the x's greater than 3, so 4, 5, 6, 7, 8, 9. Even 3.1 works. But when you have a complex fraction like this, which is something over a fraction, you want to make it into either a fraction over a fraction or 1 over the fraction. So what you want to do is you want to focus on this set right here. Add those two things together. 1 over x plus 2 plus 1 over x plus 3. What's your common denominator? Well, I get the x plus 2 from here. But what do I get from this one? X plus 3. So I need x plus 2 times x plus 3. And after I get done with this, I'm going to show you a shortcut that works when you're adding two fractions that you might like. Now, I already had the x plus 2 here, and I had to multiply it by an x plus 3 in the bottom. What should I multiply the top by? Well, what was missing from the bottom? X plus 3. So x plus 3 has got to go up top. Now, in this one, I already had the x plus 3, so what was missing? X plus 2. Add this up, you get x plus 3, x plus 2. What's x plus x? How many x's? 2 x's. Now, 3 plus 2 is plus 5. Now, here's the thing. This is not your answer. Because the only thing we did was below the fraction line. So we actually have 1 divided by, or 1 over, 2x plus 5 divided by x plus 2, x plus 3. What happens when you divide by a fraction? Can I change division into multiplication? Division, yeah, becomes multiplication by the reciprocal. So this is going to be 1 times, now what's the reciprocal of this thing? What's going in the top? X plus 2 times x plus 3 over 2x plus 5. Now, so 1 times that is just going to be that. Looking at these answers, do I have to do anything else, or is that there? Is there a fraction that has 2x plus 5 in the denominator? Yeah, B. Now, like I said, I want to show you a shortcut. Here we go. Now, a shortcut for this is, and it only works if you're going to add two fractions together. If you're going to add these two fractions together, what you do is you multiply down, like diagonally, and you're going to get A times D. And then since this is plus, this will be a plus. And then I'm going to multiply B times C. So B times C all over, you multiply the two bottom parts together. B times D. Now, like I said, this only works for when you're adding two fractions. And it's just it's a quick shortcut to get to your final answer. If you have multiple fractions, the best way to do it is to find common denominators and add from there. That's what you want to do. But if I had 1 over x plus 2 plus 1 over x plus 3, these are binomials because you have an x plus a constant, so it's a binomial term. Multiply those two things together. 1 times x plus 3 is x plus 3. Plus, multiply those two things together. X plus 2 times 1 is just x plus 2. And then I multiply the two things in the bottom. That's x plus 2 times x plus 3. And if you go through here, x plus x is 2x, 3 plus 2 is 5. Then you get your x plus 2, x plus 3. It's a nice way to add something very quickly. Now, the proper way to do it is always to find common denominators and work through that, which is what we did up here. We found that the common denominator was this times this, so I needed there. But I was missing this part, so I needed an x plus 3. I was missing this part, so I needed an x plus 2. Then add them up. You're going to get the same answer. Just so happens that occasionally, like if you're doing like 1 over 2 plus 1 over 3 plus 1 over 5, get a common denominator. Because this doesn't work. Unless you add those two and then you add a plus 1/5 to it. So you'd have to do this twice. It's actually easier to find the common denominator, which would, in this case, you could just say it's the common denominator 2 times 3 times 5, and you'll be ready to go with that. But this is a nice, easy way if you just have to add two fractions right off the bat, get them done, and move on to the next thing. If you forget how to do this, remember it's a trick. Mathematical tricks, you don't want to put all your eggs into the trick basket. What you want to do is you want to know how to do this stuff mathematically. Common denominators is where it's at. Now 15. Let's zoom in just a wee bit. This is another problem that I really like. I think this is going to be probably one of the hardest problems that you'll see on the test. It tells me that a plus b is equal to 8. And that ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14. And it asks, what are the two values for c? C can equal two different numbers. How many people got A? Alright, one person got A. B. Alright, 3 of you. C. I saw one back there. D. 1, 2, 3, 4, 5, 6, 7, 8. Okay, not a big deal. That's why we're going over these. Now, in this case, best thing to do, multiply this guy out. So, I'm actually going to use the box method. If you don't like the box method, multiply any way you want to. That's ax plus 2, bx plus 7. So this is ab x squared. That's 7ax. That's 2bx. And then the last number is what, 14? So, if I add this stuff up, I'll get ab x squared plus if I factor out an x, because they both have x's, you get 7a plus 2b, which is going to be really important, plus 14. Now, if we take a look at the original, that AB is equal to 15. Whoop. The highlighter really wants to be part of the problem. What's C equal to? 7a plus 2b. So C is equal to that whole number right here. Now, take what we were given. I know A plus B has to be equal to 8, but I also know A times B has to be equal to 15. What can A and B possibly be equal to? What two numbers can that add up to 8 that multiply to 15? 3 and 5. Now, do you know if A is 3 or is A 5? You don't know. So there's one situation, if you want to talk A and B, one case is where it's 3 and 5, the other one is 5 and 3. And this is where we're going to get our two answers from. We don't know which ones are which. So I'm going to take 7 times 3 plus 2 times 5. So I'm going to use the first set first. That's 21 plus 10, which is 31. All right, which one has a 31 in it? D. So it looks like that's the answer. And I'm just going to go one step further to make sure that we get the right answer. When A is 5 and B is 3, get 7 times 5 plus 2 times 3. 35 plus 6. That's 41. So there's your 31 and there's your 41. But the best thing is to multiply that out. Part of it's going to be A, part of it's going to be B, part of it's going to be C. Now, questions on that. Do we know how to multiply polynomials like this? If you don't know how to use the box and you use a different method, is that okay? Yeah. Do you get the idea that A times B is 15 and this is equal to C? You get that idea now? You might see one of these on there. Because it's good because it's a very good multi-step problem because that's part of factoring-ish. So you have to use some math number sense to figure out two numbers that add to 8 and multiply to 15. And then realizing that A can be 3 or 5. So I wanted you to see that one so you kind of understand why they get two different answers. And the nice thing is, since if you look at the answers, none of them repeat themselves, do they? No, they don't repeat themselves. I would think this would be a very common FOIL, an answer that would get that you would choose if you're in a hurry, because what are the two numbers that we picked? 3 and 5, and there's 3 and 5, and sometimes you see it and you said, oh, there's my answer. But that's not what C is. That's what A and B is. So the correct answer for this one is D. All right, now hold on to this because after you get a couple of these, I'm going to collect them. So this is number 1. Now take out these beasties.